to me. You're okay. Do not do it. Do not drop down. Please. It's going to get pulled in. Don't worry. The Zorb is in there.
It's dropped down.
No, you're okay. You're okay.
Go up the window.
All right.
Hail with hail.
Everybody get out. Drop it down.
Drop down.
Drop down.
Windows up.
Shit. Motherfucker stuck. Holy shit.
Is it coming back at us?
Yep.
Back up.
No, we're good. No, just drop it flush. We're good right here. Stop.
Whoa.
Please stop.
It's backing up.
Yeah, back up. Back up.
Back it up.
Back it up. Boy, we got to deploy.
Drop down.
No, go. Go. It's moving away from us. Get right up in there. Then we're going to deploy, okay? Get right up in there.
I got it.
We're fine. I'm watching you after the conclusion. You don't need to roll it up. You're fine. Deploy. Deploy the cannon now. Stop. 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 Deploy. Stop. Deploy. Deploy everything. 1, 2. Get up. Good morning, everybody. This is a live extreme weather briefing as we're going to discuss the severe weather threat on Wednesday and Thursday. I'm going to begin each of these morning weather briefings with a different storm chasing video just to set the mood a little bit as we're starting to get a little bit closer to spring storm season. And there you can see that vortex diving south across the west coast, really maximizing its amplitude as it digs south through California into northern Mexico. And then the potential of severe weather on Thursday all depends on how quickly it shears out upon lifting off to the northeast toward the Great Lakes. Recent model trends are showing a little bit more of a rapid shear out as the system ejects northeast, which would mean less of a severe weather threat across the Mid-South on Thursday. Confidence is increasing, though, for the severe weather threat on Wednesday, and that includes the potential of even daytime severe weather, daytime supercells possible across central and northern Texas into Oklahoma, possibly initiating a little bit further west of the DFW Metroplex and including southwestern Oklahoma. That could even bring Oklahoma City into the mix. Not very much change in the Storm Prediction Center long-range outlooks. This is the outlook for Wednesday that you see just below my head, and an expansion of that threat on Thursday centered across the Mississippi River Valley, the central and lower Mississippi River Valley. You are seeing the European model right now. And both of the models, both the European model and the GFS, are trending toward a quicker trough ejection. It appears more of a faster shearing out as it heads off to the northeast. The Gulf of Mexico, still warm, especially that loop current in the north-central Gulf of Mexico. I am going to show you the latest sea surface temperature anomalies. There's the European, and focus on that vortex that's diving into northern Mexico right at this time. The GFS seems to tighten up the vorticity on the north side of that shortwave, whereas the European has a little bit more of a bulb of vorticity right on the absolute base of the trough. A little bit more shear vorticity as well, helping to increase that amplitude according to the European model. Here is the GFS vortex Tuesday as it's diving south across the western U.S. and then ejection across the southern plains on Wednesday. There it is. And notice how it's a little bit more of a muddy trough ejection. You kind of have your vorticity a little bit further north in the trough axis instead of on the base of the trough. And that's why that shortwave trough shears out more rapidly. The threat on Thursday and just how significant of a tornado outbreak across the Mid-South depends on how long that shortwave trough can maintain its amplitude as it ejects from the southeastern Great Plains and up toward the Great Lakes. If it's able to maintain that bowling ball characteristic a little bit longer out of the southeastern Great Plains, that will hold that low-level jet, maintain its magnitude, and also help to expand it across the Mid-South on Thursday. And that would mean more of a tornado outbreak during the day on Thursday. But if this trend continues toward a more rapid shear out as it ejects from the southeastern plains, then there is a decent chance that Wednesday is going to be the bigger of the two of those severe weather days, and that would mean southern Oklahoma, North Texas, DFW area as well. So here are the latest sea surface temperature anomalies. This shows you the La Nina that continues to rage across the tropical Pacific. If you look below the surface, however, you can start to see some warm anomalies that are propagating from west to east across the central Pacific below the surface. And that's likely going to be the first sign that the La Nina is going to begin to transition toward an El Nino or even neutral sea surface temperatures. That'll probably happen closer to summer. But all of these cold sea surface temperature anomalies that are in place across the tropical Pacific, they have to go somewhere, and they're going to propagate around the eastern periphery of the Pacific Ocean through Kelvin wave propagation along the eastern boundary. That's why you have this belt here of neutral to slightly below average anomalies across a subtropical branch of the PDO. This is the PDO horseshoe. It's basically on the west to east axis, and it encapsulates the warm anomalies within that are the North Pacific Oscillation. And this type of a configuration, as you go into the spring, winter into spring, should favor a ridge closer to the Central Pacific, and then the tendency for the formation of a Western North American trough. And you're definitely seeing that configuration with this trough ejection, with that shortwave, increasing amplitude as it dives south across the western U.S. into northern Mexico, maximizing its amplitude on approach to the Great Plains, maintaining that amplitude into the mid-south. And that's why I think that we expect a pretty active tornado season from the southeastern Great Plains across the mid-south, the central U.S. as we progress later on into the spring. And you can also see the reds there in the Gulf of Mexico. Definitely some slight above normal temperatures. And let me get rid of my broadcast there, and there you can see the loop current is a little bit warmer, so there definitely is some warmth in the Gulf of Mexico, especially the central Gulf of Mexico. It does look a little bit noisy right now because of those Arctic fronts that have passed through, but it is definitely above normal. And more importantly, the Caribbean Sea is above normal, and so we have that anticyclone off the southeastern U.S. and over the Caribbean, helping to maintain those sunny skies, the above normal temperatures down there in the Caribbean Sea. And that's what's going to fuel the Gulf of Mexico, the moisture. So you have this reservoir of 70s dew points sitting down on the western periphery of that anticyclone in the Caribbean Sea. So then a trough comes in, dives down to the western U.S., arrives in the southeastern Great Plains, and it's very easy to pull up that moisture, that reservoir of 70s dew points sitting over the Caribbean into the Gulf of Mexico, and then to fuel these trough ejections. Last year was a year one La Nina, so you didn't really have the cold sea surface temperature anomalies that were populating the PDO horseshoe further north, a subtropical branch of the PDO horseshoe, and this branch, which is even more important across the extratropics, the Gulf of Alaska, northeastern corner of the Pacific. And that's why we're getting this run of these troughs that will increase their amplitude down the western North America and then eject and maintain enough amplitude to bring even a tornado outbreak or two across the mid-south. And that's what we saw during the late fall into the winter. December 10 and 11 were very similar to that trough ejection. But one thing that is very important and critical to maintain that amplitude as the trough ejects from the Great Plains is, at least on December 10 and 11, was the interaction of the parent trough with a closed low that was off Baja. And the perfect timing, the phasing of those two systems helped to maintain the amplitude of that trough as it ejected from the southeastern Great Plains and across the mid-south. That's what led to that substantial tornado outbreak on December 10 and 11. We also saw a similar trough ejection December 31st into January 1st, that tandem trough ejection. But there were some other factors that mitigated that tornado outbreak from happening. But this one is a more clean trough ejection. You can see like spokes on a wheel, two spokes at least. You have that lead trough ejection, and then you get the deepening of that short wave on the backside, which helps to pivot and shear out the lead vortex as it ejects toward the Great Lakes region. And that's the latest trend that we've seen in the models, is toward a rapid shear out. There you can see it approaching the southern plains, and then it ejects off to the northeast, quickly losing its amplitude as it heads toward the southern Great Plains or Great Lakes. That would still lead to a severe weather outbreak across the mid-south, but more of a strung out squall line with embedded tornado circulations within it. But if this trough is able to maintain its amplitude after it leaves Texas and Oklahoma just for a couple of clicks there as it's heading into Thursday, then that would lead to a potential tornado outbreak across the mid-south. So all of it depends on how much this bowling ball of a trough is able to maintain its amplitude as it leaves northern Mexico, approaches the southern plains, and then ejects across the mid-south. So that's really what we're trying to figure out. We head back to the forecast models. This is the GFS solution. This is last night's 0Z GFS, showing kind of a more of a messy trough ejection on Wednesday evening. But still, this type of a trough ejection would still maintain severe weather potential across East Texas, even though you do have that slightly more veered appearance to the low-level jet. We'll head on over to the European model, showing you that western gradient of the low-level jet west of I-35. And let's drill down a little bit closer to the Southern Plains region. There you can see the core of that low-level jet right over the DFW area. Wednesday afternoon. Let me center this as well. So I do think that the potential for daytime severe weather and storm chase potential is increasing for Wednesday afternoon. Slightly faster timing of that trough as well, arriving near peak heating. That'll help to tighten up that dry line as well on the western gradient, probably further west of that low-level jet. Oftentimes these early season events in the southern plains will have a low-level jet axis that's a little bit east, and then your instability axis will extend well to the west. Storms will initiate to the west of that low-level jet and then move into the greater wind shear, especially as you get the overnight, and then you'll get the development of these prefrontal confluence lines. Right now, the European model shows near 60 to the low 60s dew points, pumping northward along that I-35 corridor all the way to DFW. Not as favorable of a moisture situation up in Oklahoma, but I think as we get closer to the NAM model and the convective allowing models, and will also show a tighter vortmax, more of a bowling ball ejection from the desert southwest in northern Mexico, I think we're going to see more tighter surface features. You're going to see a tighter dry line here across North Texas. You'll see a tighter 850 low, more rapid lee cyclogenesis across the southern high plains. And then I think that we'll see more of a tight dry line for the initiation of storms along that. That's what's going to need to happen to get daytime initiation of storms across northwest Texas into southern Oklahoma. Otherwise, there's definitely going to be the development of a nocturnal severe weather event off to the east. That front is going to initiate storms likely near and to the west of Dallas-Fort Worth. Just after sunset, you're going to get that rapid moisture advection across East Texas. That's your European moisture situation. There's your GFS moisture situation for Wednesday night, showing you deeper dew points across southeastern Texas that would be available for initiation of those storms. So really what we need to wait for is as we're getting within the NAM range, within about 84 hours, and then we get within the convective allowing models, and I think we're going to see a much tighter dry line here across North Texas. But if you buy the global models this far out and start to drill down on these fine scale features, at the very least, it is showing a nocturnal event to develop across East Texas, southern Arkansas, covering the state of Louisiana as well. And a weaker surface low with this more rapidly shearing out system as well. But then finally that surface low lifts off to the northeast over southern Missouri by Thursday morning. Likely we'll have a squall line ongoing off to the south of it. There's the squall line starting to approach the Mississippi River Valley, 997 low over southern Missouri. And then as you go with this more rapid lift up to the northeast, up toward the southern Great Lakes, the timing isn't as favorable for a big-time severe weather event across the Mid-South either. That system ejects toward the Great Lakes as a shearing out upper-level system. Not as powerful of a surface low, but still a 995 low. Nice arc shape to the surface pattern. This would still have tornado potential. This is at 18Z, or this is 15Z, late morning on Thursday. Squall line going. We'll likely see some prefrontal confluence lines that will develop across that open warm sector. Dew points a lot more substantial, mid to low 60s, surging northward up into central Tennessee. We're probably going to see these dew points go up as we get within the NAM model range. But the timing is not as favorable with that more rapidly shearing out system as it's heading up toward the southern Great Lakes, but you still have this nasty 70 knot low level jet late morning toward midday. It'll be interesting to see what the 6Z models and especially the 12Z models show with this, or if we're going to trend back toward a slower solution. It looks like the 6Z models are on par with the 0Z solution last night. Can also look at the amplitude as well. Does look like the timing of the ejecting system is definitely a discrepancy. And looking at the ensembles, the models differ a lot in how long this shortwave trough is going to maintain its amplitude across ejection from the southeastern Great Plains up toward the Great Lakes. If it's able to maintain that bowling ball appearance a little bit longer on approach to the Mississippi River Valley, a slightly slower ejection as well, then I think that the Mid-South will likely have a tornado outbreak. And probably will anyway, even with this type of a trough ejection. Nasty 70 knot low level jet just ahead of that squall line. Huge photographs. The thermodynamics will still need to work themselves out. The global models always kind of show slightly lower temperature bias, a cool surface temperature bias, and a little bit less moisture. And then as you get within the mid-range of the NAM, and especially the convective allowing models, then you really start to see those thermodynamics come together. But look at that photograph, just picked over northeastern Mississippi randomly. That's what happens when you get a 70 knot low level jet in the 1 kilometer range. You get this massive photograph that would favor strong tornado potential if the thermodynamics are able to work out. Your surface wind about 20 knots out of the due south. Your 1 kilometer wind increases up to 70 knots out of the south-southwesterly direction, well backed as well. And then your upper level winds increasing as well, 60, 70 knots out of the due southwest, directional shear, speed shear, contributing to this 40 knot 0 to 1 kilometer shear vector. Your storm motion southwest to northeast at about 50 knots, a very rapid storm motion. Classic Dixie Alley type storm motions out here, very kinematically strong environment. Classic winter trough ejection here as well. So this is definitely going to be a storm chase. It's just whether it's going to be a 2-day outbreak, or am I going to target the Southern Plains on Wednesday and sit this one out? I don't think so. Definitely going to chase this Thursday event. Look at that surface low at 12Z near the Missouri boot heel. A little bit faster, more sheared out compared to the forecast models yesterday, but we're going to keep on breaking down the operational models. We'll look at the ensembles to assess uncertainty as well. But this would definitely favor a tornado outbreak, just not the most favorable timing for this trough ejection to have a major outbreak across the Mid-South. Hopefully that doesn't happen. Hopefully we continue the trend toward a more sheared out trough, toward a quicker trough, and more southwest unidirectional flow down the squall line. But right now it is looking like the Mid-South is going to be quite active with an outbreak of at least severe weather, and it could even be more substantial. Look at that surface low bottoming out in the low 990s on approach to the southern Great Lakes. This would also lead to a nice swath of snow on the northwest side of it. The exact track we still need to iron out. But right now it is shifting a little bit further south now toward what looks like a Chicago, northern Illinois. Not a huge stripe of snow, and when it's not being indicated by the GFS, which will often overdo the snowfall. And I think that the story of this one is definitely going to be that severe weather. There's your European swath of snow. Looks like southern lower Michigan gets hammered, where I grew up, northern Indiana. Double-digit snows up there as that surface low gains strength on approach to the southeastern Great Lakes. So my plan is to leave early next week, and I'm going to leave in Dominator 4, and of course I'm going to target North Texas. If it is a nocturnal event, then I definitely will target that. But I do think that as we get closer to the mid-range models, that there is a chance of an increase in that threat of even daytime initiation of storms across the southern plains. One negative that could prevent that is it is kind of a late arrival of the moisture off the Gulf of Mexico. And there could be a late arrival of that moisture as well, even though the European is showing these mid to upper 60s dew points across the Gulf. You're not seeing those 70s down here yet arriving from the Caribbean Sea. So that certainly could mitigate the potential of daytime initiation of storms along that dry line. You do kind of have this more diffuse dry line structure, which is classic for this late arrival of the moisture on day one. But by day two, there should be plenty of moisture available for the Mid-South. You can see the arrival of these 70s dew points, those purples down into the Gulf of Mexico. So I do think that Thursday, moisture is not going to be an issue. On Wednesday, it could be. That late arrival of the moisture might prevent daytime initiation of those storms across northwestern Texas into southwestern Oklahoma, moving into central Oklahoma. Most of the models are showing a more unfavorable low-level moisture situation across Oklahoma to the north of the DFW Metroplex. So thank you, everybody, for tuning in to this weather report. I am going to be doing a live Q&A for supporters only, exclusively. I got to get back on that, supplying those exclusive weather reports where we could really drill down and look at the individual models and the ensembles in detail. So thank you, Facebook supporters, for making these live briefings and live storm chasing possible. We're going to be doing that live Q&A tonight at 7 p.m. Eastern Time. And I'm going to be doing a post on that as well. That live Q&A will be an hour. That'll be this evening. We'll break down the 12Z models, transitioning into the 18Z models. We'll look at the 12Z ensembles as well to see where the model discrepancies are located. We'll also look at some individual photographs too. We'll talk about the potential for daytime initiation of supercells across North Texas into southern Oklahoma. That's going to be tonight, 7 p.m. Eastern Time, live Q&A exclusively for Facebook supporters. Thank you, everybody, for tuning in here for this live.
Boy, we gotta deploy! No, go! Go! It's moving away from us!
And I look forward to seeing you, Facebook supporters, this evening, 7 p.m. So I hope you enjoyed this video. Intercept of the Coleridge, Nebraska tornado, June 17, 2014. This was actually a 3-day storm chase, the rare 3 in a row where you get tornadoes on each day, June 16, June 17, June 18. We saw the Pilger twin tornadoes, those twin EF4s, the day before this on June 16, 2014. Similar to 2013, 2014 featured basically a 2-week-long tornado season where you saw all your severe weather, all your tornadoes, all your storm chasing happen during that time. And then the rest of the season was relatively inactive. 2013, though, happened a little bit earlier in the season during May, where you had May 17. You had May 18, the Roselle, Kansas tornado. You then had May 19 as well, the outbreak across Oklahoma, the EF5 and Moore, Oklahoma on May 20, 2013. And then you also had the Bennington, Kansas tornado, the Cora, Kansas tornado the day before toward the end of May, May 29, May 30, May 31st. Then you had the infamous El Reno tornado to the west of Oklahoma City. And very similar to that in 2014, you had about 3 days of tornadoes, basically a 2-week period there in mid to late June where it was very active for tornadoes. And then this season just shut down. 2015 was a very active tornado season across the southern plains. Had a very energized subtropical jet, a lot of flooding as well across the southern plains, Oklahoma and Texas. 2016 was also a very active storm chasing season across southern Tornado Alley. 2017 and 18 were also pretty active tornado seasons. 2018 and 17 started to focus more across the high plains, and you had a couple of intercepts across the southern plains. 2019 was a very active season across traditional Tornado Alley, the Great Plains, and the central U.S. And then we've had a couple of down years, 2020 and 2021. Big hail, though, massive gorilla hail over the last couple of years. But now I think that we're going to transition to a more active traditional Tornado Alley, central U.S., mid-south, because of those reasons discussed due to the Pacific climate system and that cold PDO across the northeastern Pacific and the subtropical branch of the PDO as well. So thank you, everybody, for tuning in to this weather report Saturday morning. Never stop chasing.